Greetings from Mobility Outlook and welcome to Mobility Conversations. Today we have with us Mr. Rajendra Petkar, Chief Technology Officer at Tata Motors. He is going to talk about ACE EV that was launched on 5th May, exactly 17 years after ACE was launched in India. Welcome, Mr. Petkar.
Thank you.
What is the evolution of electric vehicle per se at Tata Motors? Yeah, I think Chairman told that it was from 2018.
Yeah, so we began our journey from 2018, that time, and for the reason that the country is facing number of challenges. The India has the dubious distinction of hosting 14 out of the 15 the most polluted cities from the world. And also the another challenge that India keeps importing the crude for the consumption domestically, and therefore that also has the adverse impact as far as the forex outgo is concerned. So these are the two challenges which are being faced by India for a long period of time, and therefore we thought that while there has been the incremental approach in terms of compliance to the regulations from say Bharat Stage 1, Bharat Stage 2, 3, 4, and then there was a leapfrogging that was done from Bharat Stage 4 to 6. But we felt that unless we go for a zero emission vehicle technology, this kind of the getting the right quality, ambient air quality will not be possible unless you go for the clean technology, zero emission technology. So therefore, we had an emphasis on the battery electric vehicle since then. Actually, we have been experimenting various technologies even much before that. But I think as the luck would have it, everything had fallen in place around 2018, where a lot of support that came in from the government. The government has been quite proactive when it came to the electrification, and also a lot of commitments came from the government, not just providing the incentive, but also the commitment in terms of providing the infrastructure required for the charging. It started in 2018, and then various state governments also have picked up. And as on date, as we speak, there are a number of state governments who have also been offering the incentives for the electric vehicles. So, in addition to let's say the national challenge of the urban air pollution, and also about the import of the crude, we felt that we have a duty as far as the larger ecosystem and the environment is concerned, in terms of being sustainable, in terms of offering the product and the technology which have the least impact as far as the environment is concerned. And therefore, we were also internally committed that we need to focus on these technologies going forward. So the ACE EV is the natural culmination of that, and we started work on the ACE a couple of years back, and then we decided what should be technology, what should be strategy, and how we should actually create the product which is going to make a big impact in certain market segments.
Thanks for your giving a comprehensive picture. Disruption is at its peak, especially when it comes to electric vehicles. Every day there is some changes in battery, BMS or whatever. What are the challenges you face, because you started 2 years ago until now?
Yeah, so I mean the whole disruption, what you say about the electrification. The electrification is a part of mega disruptive trends which actually came in. And I remember in my internal communication and internal town hall, I used to say that this global megatrends and the global disruption is going to come, right? And that I used to say in 2018, 17, 18, around that time. And, in a very quick span of 6 months to 1 year, I changed my tagline to say, the global disruption is here at our doorstep, right? So it's not like it's going to come, it's already at your doorstep. And then, as we have been delivering the products which are quite sophisticated in terms of technology, in terms of zero emissions, in terms of connected vehicle features, safety, I can go on and on. if you look at all the recent launches across passenger and the commercial vehicle. So therefore, we have come a long way in the last 4 years in terms of the product profile. So I have changed the tagline now. Therefore, I say that now we are riding on the megatrends and the disruptions which are happening in the technology. So I can say that we are just absolutely on that now, and we are now creating the segment leading products now. So gone are the days where now we are riding, but actually we are now directing.
Okay.
Where the technology should be heading.
Okay. From riding to directing. Interesting. If you can tell me a little bit about the vehicle architecture per se, because there are only four elements: motors, battery, controllers, and then a cable, etc. Each company follow a unique pattern. So if you can.
Yeah. So ACE EV. We actually look at the what is the duty cycle the vehicle is going to do. And what we have launched today is the ACE for the cargo segment, and more specifically for the e-commerce, where they have the fixed duty cycle, and the type of the goods, category of the goods, the nature of the duty that the vehicle is required to do. Let's say 24 hours. So when it starts, how much distance it covers, where it takes us, halt, how many starts and the stops are there, what's the acceleration level, what's the route terrain. So all of that is something becomes a sort of an input to the product development engineers, and therefore considering those inputs, then we decided what should be the strategy, and we chose not to get into something which is going to be suboptimal in terms of a technology, and therefore we did not go with the air cooled batteries. It's the liquid cooled battery that we have. We have the force air cooled the traction motor. We have very advanced the battery management system here, which actually does the monitoring of the complete battery pack from the safety point of view, and also from managing the energy efficiency point of view.
Okay.
So beside the technologies which are related to the electrification, like the batteries and the motors and the BMS, the motor controller, the vehicle ECU, uh, what signifies, let's say, the electric vehicle. So from my point of view, beside being the powertrain to be electric, you also need to have some degree of a sophistication, like the connected vehicle features, right? Because then the
Makes sense.
the user of the vehicle need to know where can I charge, how much charge is left, and therefore all those kind of a functionalities which normally become possible when you have the strong telematics control unit sitting on the vehicle, and also then you can add more number of the value added features on the TCU, which will actually effectively help to optimize the trip. So there are many such kind of features and the functions, and if I'm not mistaken, about 20-21 of them are the part of the ACV.
Okay.
If you open the door and look at the cockpit, it looks something different, because we are offering the largest screen size, 7-inch. It's like a car, like the infotainment system what we have, and the vehicle also comes with the voice recognition technology. Of course, not all the models, but wherever it would, and somebody is willing to pay for that. But then that's where the technology is going, and we thought the voice recognition is going to be important, and even the category of the customers, the category of the drivers, everybody would like to have something which is going to be unique.
Okay.
So these are the, I would say, beside the powertrain, beside the battery motor, there are other technologies. There is the TPMS, tire pressure monitoring system, on the vehicle. So it's a full bouquet of the things that we have on the ACV.
Okay. What are your initiatives from the design for manufacturing point of view, design for assembly point of view, and also design for serviceability?
Yeah, so we call in our language the concept of a 4D, right? So we at a right gateway in the product development process, we have a sign off with all the downstream agencies. So R&D creates the design, but the design is supposed to be designed to cost, designed to manufacture, designed to service, designed to the assembly dismantling. You look at the previous failure modes, if at all, and then how you have taken care of it. So all of that is a part of an internal process called as a 4D sign off. And then once the design is created, then we actually ask the downstream agencies to look at it, and then through the series of the workshops, finally there is an alignment. Yes, this is manufacturable, right? This is okay as far as the cost is concerned. This is as far as serviceability is concerned. So it's a part of our the mature design and the development process that we have in the organization.
So you have taken all aspects together. That means the uh, vehicle uptime will be
Yes.
far better than the diesel counterpart.
Yes.
To what extent?
See, I mean, if I go by the data point that we have already, because we have supplied about 645 urban buses, electric buses, and those buses have been operating now.
95%.
Yeah, more than 95% is an uptime. And these are the category of the applications, especially the e-commerce. You cannot afford to have a downtime, right? So therefore, that is the minimum standard that we have, and of course, we are going to do it much better.
Okay. If you can talk a little bit about the placement of the battery, like for example, to optimize the COG and also space. Some companies have kept the battery between these two. What is it called? C channels.
Yeah.
Sachet.
Frames. Yeah.
To frame and also spread across. And even in the case of cabling, they have some unique structures. If you can throw a little more light on this.
Yeah. So the positioning and the placement of the battery is very important because the battery is heavy, right? If you locate the battery too much in the front, there is going to be the load that is going to come on the steering wheel, and also the brakes. If you locate on the rear side, there could be the tail sway that can happen to the vehicle. So therefore, the batteries are the way that we choose to locate the battery is to do the good balance in terms of the load that comes on the front and the rear axle. Keep it at the center. Be mindful of the ground clearance, and also that in the event that there has to be unfortunate event of a crash, either to the front or the rear or on the side, the battery should be remain well protected. Although battery per se and the system per se that we would test and evaluate and validate from all the external shocks and the impacts. But then that is the criteria that when you position it that way, that in the event something happens, the battery is going to be not explode, or there is going to be some thermal runaway, those kind of things.
So it is sitting on the sachet or within the sachet?
Yeah, it's between the
members.
Yes.
And okay, between the members.
Yeah.
And then the cabling, for example, you see other than the motors, you have the front axle or the rear axle?
Front.
And the front. So the charging point is at the rear.
Weight and plus the length, and I mean, you need to have the very neat and clean layout.
Correct.
For the wiring. They're all high voltage systems.
Yeah. See, electric vehicle always need to have a lower rolling resistance tires. So at the same time, the regenerative braking that acts actually against. Correct me if I'm wrong. So how do you optimize this?
Yeah, so I mean, there is not so much of an interplay between whether you have the low drag tires or not. But as far as the regenerative braking is concerned, what is the purpose? I mean, you would like to actually recover the energy that you would otherwise lose in terms of the braking, right? And so therefore, the best thing is to actually use the regenerative braking, right, in a manner that you can apply. When you apply the brake, you are able to absorb the energy and feed the energy back into the battery. So that's how it's a closed looping that is done. But not so much about whether it's a radial tire, whether it's a bias ply, whether it's a low friction.
Okay.
It's something there is no such straight correlation, I would say.
Okay. Typically, commercial vehicles, if we take, generally they are abused rather than used. Correct me if I'm wrong. Overloading, etc.
Yeah.
But the e-commerce segment is slightly refined because they have a fixed size, etc. But in case when you're launching it for other applications, you must have considered certain aspects. If you can throw a little more light on this.
Yeah. So especially if you look at the ACE category segment, there are absolutely varied market practices, right? So when it comes to e-commerce, it's a very disciplined way of running and operating the vehicle. But otherwise, the market practices are there in terms of people become very adventurous in terms of what should be the deck height, what should be the deck length, and what category of goods, including the duty cycle, right? So it's a challenge. It's going to be a challenge. But I think it is also important to set the expectations right
Okay.
when it comes to the end consumer.
Okay.
I mean, you cannot expect the same performance,
Correct.
the 400 kg payload and then do it, 1000 kg payload. So I think those expectations and the education is important to the end consumer.
So that will be done through dealerships.
Yes,
And,
yes, we will be engaging with the customers, and especially for electric vehicle, it's going to be important that we, engage with the customer. We understand what's their duty cycle, and then they also need to, work with us in terms of whether their expectations are getting fulfilled or not. It's going to be a journey which has to be together.
So that means the journey with the customer will be much more effective and longer than the ACE diesel.
Exactly. So it's going to be more collaborative. Yes.
I think you have developed this product along with the suppliers and also getting feedback from your customers. So are there special initiatives taken by you for the supplier development and form part of this?
Yeah, so we have the big supplier community, and they have been an integral part of our development process, and therefore ACE EV is not at all an exception to that.
Okay.
And I think we have a good I would say the suppliers here who are quite capable. They understand the local operating conditions. They also understand the need for localization, because if you have to go for the FAME to benefit that if you have to take, or the benefit of a PLI scheme, then they know exactly that what they need to do, and therefore these are the suppliers who have, in some or other way, they have their own R&D center in the country. That's important because we look at that, because we just don't want something coming directly, outside to in. There has to be local value addition that must happen in terms of either design, re-engineering, or the localization.
When you design, you always look at standardizing. The standardization is a key thing to optimize cost. What are the initiatives here?
Yeah, so therefore, I mean, we have a concept we call that as a PMXU. PMXU. P means, for any given program, we would like to maximize the P. P means what? It's a carryover. So, let's say the ACE EV. How much maximum that you can carry over from the current ACE? That's the P part. M is if you cannot carry over, then you modify, right? That's a PM, M part. X is something which is unique, right? Unique, which is going to be there only for this program, right? And the U is something it's a unique for this, but can be used for some other vehicle.
Okay.
So we have this concept of a PMXU, and therefore, as much standardization we can do, actually it helps to give you the economy of scale.
Okay. So to what percentage will there be a commonality between ICE and electric?
I would say to a large extent, I would not hazard the guess, because we have the various matrices for that. Either by value you can talk about the carryover, or by number of parts you can talk about the carryover. Let's say 50% parts are carryover. Now that's meaningless. But if I tell you 50% by value is carryover, the parts can be fewer, right? So, but there are a number of such the parameters that we go through as a part of a program development.
Yeah. When it comes to the GVW, what kind of changes that you have between ICE and diesel?
So between diesel and the ACE EV, right? That's the question. Yeah. So in terms of the GVW, there is an increase because of the battery, right? And therefore, but that has been taken care of through the work that we had to do in terms of some structural member reinforcement, looking at the kind of the brake performance that we need to have, the efforts, the steering wheel efforts, how they can be maintained, because everywhere you find that there is the impact of a load, right? So there has been a re-engineering to a large extent to make sure that the increased GVW is very well addressed, as a part of a program.
Thank you, Mr. Petkar. Thank you so much for
Thank you.
sparing your time.
Thank you very much.